Good. So let's get started. We'll talk about vector parametric and symmetric equations of a line in R3. You will see the title seems very similar to the one from 2 days ago, vector parametric equations in R squared. Now it's R cubed, and we're going to add a new type of equations. We won't think too much. Okay, so how about before we start, how about I refresh your memory, review in terms of vector and parametric equation of a line in R squared. What was the whole idea there? The whole idea was starting with what do I need to create to write the equation of a line in R squared? Well, let's assume this is the line we are talking about. I need a direction vector M that gives me the direction, and then I need to fix a point P0 on the line, and that point gives me R0, the position vector. If I have that, I can generate any point on the line by adding to R0 multiples of M. Good. So that was the idea. R can be written as R0 plus T times M. T is a real number. Okay. So what stops me from doing the same thing in R cubed? What do I have here? I want the equation of this line that you see right here. And guess what I need? I need a direction vector M. This is my direction vector. Now I am in R cubed now, so as a result, how am I going to write that vector M? I'm going to write vector M as, let's be consistent with R squared, A, B, and C. These are the components. Then, of course, that's not enough. The direction vector is not enough because that gives me, can be any line, that could give me any line parallel to this direction vector. So I need to fix a point. Let's fix a point. When I fix a point, I need a position vector to that point. That's my position vector. So this is vector R0. How am I going to write this? X0, Y0, Z0. So there you go, absolutely identical to what I did for the line plane. I'll do for the line is 3D. I'm going to write R as any point on the position vector to any point on the line as R0 plus Tm, where T is nothing else but a real number, right? So I'll go to the line with R0, then I will add multiple of N0. Take N0, add multiples, add, I don't know, 0.4, M is this point, whatever, all these points, the other way, there you go. So this is, you can generate any point on the line. Good. So there you go, that you have your vector equation of the line, vector equation of the line. How am I going to write my parametric? Well, R is nothing else but x, y, z equals x0, y0, z0 plus t times abc. As a result, I can write my parametric equations of the lines as x equals x0 plus a, y equals y0 plus b, and z equals z0 plus tc, where t is a real number. What did I get here? Nothing else but parametric equations of a line. Good. Next. Look what I'm going to do now. Sometimes it's useful to rewrite these equations by isolating t from each of these equations. So from the first one, I'm going to isolate t as x minus x0 over A. From the second one, P equals y minus y0 over B, and from the third one, T equals z minus z0 over C. Well, it's the same T, so it means that those three expressions must be equal. So there you go, I can write something like that, where I have to make sure that A, B, and C, A, B, and C are all different from 0, and this is nothing else but symmetric equation of a line in R3. Guess what? We are done with the lesson. Before time